And like I said, this is going to be like a two-part. This is a part one. We're solving square root equations. So specifically, we'll have like a square root of x equals like 16. And then we're going to have to solve for x. That's our goal for today, is we can solve simple square root equations. So nothing too complicated. It'll just be the square root of just x by itself on the inside. Okay. So for prior knowledge, it says to solve the equation. It's not on your actual notes, but you guys can do it on the front cover of your booklet. The front cover of your booklet. You guys can do this prior knowledge here. Okay, you can do this on your front cover of your booklet. We got the square root of x over 4 plus 2 equals 7. So remember here we're doing PEMDAS in reverse. Please excuse my dear Aunt Sally in reverse. So first get rid of any addition or subtraction. Then get rid of any multiplication or division. If you have any exponents, and the parentheses are at the end. Okay? So work backwards. Get rid of any addition or subtraction. So do I have addition or subtraction? I have a plus 2, right? So do the inverse of addition. You subtract 2 to both sides. And then I have x over 4. That's a division. So the inverse of division is to multiply both sides by 4 at the end. Okay? So first subtract 2, then multiply by 4, and see what you get for your answer. All right, next that brings us to our concept slide. So in our concept slide, we can see that we have a radical equation. So a radical equation contains a variable within a radical. So I can see the variable is under the radical here. And it has an equal sign. So it's a radical equation. My variable is under the square root. So it's a radical, and then because of the equal sign, it's an equation. Or it says, or a variable raised to a non-integer rational exponent. So non-integer means like fractions. I can see this x plus 5 raised to the 1/2. So raising it to the 1/2 is the same thing as a square root. Basically, the 2 underneath it is that means it's a the index is 2. So it's the square root. That basically is the same thing as the square root of x plus 5 equals 9. Okay, and again, I can see an equal sign, so then it's an equation, and it's raised to the rational exponent, like the 1/2. So that means it's a radical equation. For the third one here, I can see that this is a cube root of the x squared. So the cube root is still a radical, and the variable is under the radical, and they have an equal sign, so it's an equation. But for these, the 3 right there, this is a cube root. So we're not going to learn about solving cube roots until like our third lesson. Because our objective is to simplify square root equations. We're only going to be focusing on the square roots today, which will look like this. Okay? All right, then I have non-examples at the bottom. The non-examples, notice, even though I have the square root of x there, but there's no equal sign, so then it's not an equation. On the second example, I don't have a radical, like I don't have a square root, so then it's not a radical equation. That's just a regular equation. It's a linear equation, not a radical equation. The last one, again, there's no equal sign, so then it's not an equation, it's just an expression. So in order for it to be a radical, the variable has to be under the square root, and in order for it to be an equation, I need to have an equal sign. So our next concept slide here, we have the steps to solve a radical equation. Our step 1 is going to be to isolate the radical expression. Meaning here we're going to undo any addition or subtraction. So basically, I'll just write it out. We're going to undo addition or subtraction, then multiplication and division outside of the square root. Undo any addition or subtraction, then undo any multiplication and division that are outside of the square root. Okay, step 2 says to raise both sides of the equation to the appropriate power. In this case, we're only going to be doing the square root equations. So in this case, that basically means we have to undo the square root. And how do we get rid of the square root? Does anybody remember? What's the inverse of taking the square root? How do I cancel the square root? Anybody remember? No? We'd have to raise both sides of the equation to the what? To the second power, right? So that's called squaring both sides. We would square both sides to get rid of the square root. And then our step 3 is to solve the resulting equation. And in order to solve the resulting equation, basically you undo any addition, subtraction, undo addition and subtraction, then multiplication and division that was inside the square root. All right, then our step 4 is to then check for extraneous solutions. And extraneous solutions, we saw this when we were looking at rational equations, but extraneous solutions basically mean any solutions that fail to make the left side and right side of the equation equal. So like, for example, if I get like a 2 equals 5, 2 does not equal 5. If I get like a 3 equals 0, 3 does not equal 0. So the left side does not equal the right side. Those would be extraneous solutions, okay? Or the other way I can get extraneous solution is anything that produces imaginary values would be considered extraneous. So how do we get to imaginary values? That would be like taking the square root of a negative. If I had like square root of negative 2 or square root of negative 4, these would be considered imaginary or not real because there's no possible way to get a negative by multiplying the same number by itself twice. So if I take a positive number and multiply by itself, that'd be 2 positives. 2 positives gives you a positive. Or if I take a negative number and multiply by itself, that's 2 negatives is also a positive. So there's no way I can get a negative by multiplying the same number by itself twice. So that is called a non-real, it's imaginary. So if you have anything that's imaginary, then it would be extraneous solutions. Okay, so just to recap one more time, is we're going to do PEMDAS in reverse with anything outside of the square root. Then you get rid of the square root by squaring both sides, and then get rid of any addition, subtraction, multiplication or division that was inside of the square root. So basically do PEMDAS in reverse, get rid of the square root, and then do PEMDAS in reverse again, okay? And then at the very end, you check for extraneous solutions. So let's look at our first example. We're going to have the square root of x equals 4. And you might be able to fit like 2 examples in each box. They're very, like, it doesn't require that much work. So we got the square root of x equals 4. All right, so I'm going to kind of move it over to the side. I'm going to work, well, I guess it doesn't matter. Sorry. All right, so if I look at our step number 1 was to get the square root by itself on that side of the equal. So square root of x, do I have square root of x by itself on that side of the equation? Yes. So step 1 is already done. I don't have to isolate it. It's already by itself. So then our step number 2 is to get rid of the square root. In this case is our step 1. So undo the square root. How do we undo the square root? We would have to square both sides. Okay? That way the square root would cancel out the squared, and I'd be left with x equal to this 4 squared. Remember, that means 4 times 4. So what's 4 times 4? 16. Okay, I already have a solution. It's a possible solution though. So then I have to go back and I have to go check it. Okay. So my third step here, or I guess second step really. Oh, she's not here till does it matter?
Oh, you can just toss it.
Okay. What was I saying? Sorry. Our next step is to then check it. So we're going to now check your solution by plugging it into the original equation. Okay? Check by plugging it into the original equation. I had the square root of x equals 4 is the original equation. So I'm going to plug in my x value, which was 16. Okay? So then I have the square root of 16, and I'm checking to see if that equals 4. Okay? I'm checking to see if the square root of 16 equals 4. But when you guys check it, you do not move anything to the other side. This 4, you leave it by itself. You don't do anything. You just check, what is the square root of 16? 4. And did 4 equal the right side? Does 4 equal 4? Yes. That means that this x equals 16 is a valid solution. So x equals 16 is my final solution. It's not always going to be valid, so you always have to go back and check it. Okay? And then we're done with that example. In your notes, like I said, there are a lot of examples and not enough boxes in your notes. Let me see. Let me open up the book. So you guys have like pretty white boxes. You guys can like draw a line halfway through, like wherever you just finished, and then just do the next example right next to it. They don't require that much work. So let's go ahead and try the next example. All right, go ahead and copy. We have the square root of x minus 2 root 3 equals 0. Square root of x minus 2 root 3 equals 0. All right. So again, my step number 1 is to isolate the square root of x. Get the square root of x by itself. So this time I do have something on that side of the equal. I need to get rid of this here by doing PEMDAS in reverse. So first get rid of addition or subtraction. Do I have any addition or subtraction? I have a subtraction, so we need to get rid of it first, okay? So first, isolate the radical. So we're going to add 2 root 3 to both sides. Okay, that's going to cancel those right there. And I'm going to be left with the square root of x equals 2 root 3. Okay, now I have the square root of x by itself. So the second step now, again, is to undo the square root. So how do I get rid of the square root? We're going to square both sides. So then the square root cancels out the squared, and I'm left with x equals, I have that weird 2 root 3 squared. So whenever that happens, that's actually 2 times the square root of 3. So our exponent rules say we need to distribute the 2. So take the 2, distribute it to a 2 squared, and then distribute it also to the root 3. So that's a 2 squared times a root 3 squared. Okay, then step 3, we're going to solve. So I got a x is equal to, this right here, 2 squared was 2 squared, which means 2 times 2, which is 4. And the square root of 3 squared, I'm going to do this on the side, but the square root of 3 times the square root of 3, which is going to be the square root of 9, which is just going to be 3. Or, basically, the square root cancels out the squared, so I'm going to be left with 3. 4 times 3 is going to give you, what's 4 times 3? 12. I got x equals 12. But remember, now I have to go check it. So step number 4 is to now check it. And I check it by plugging it into the original equation. Okay? So my original equation, I got the square root of x, but my x, we just calculated to be 12. And then I got the minus 2 root 3. And I'm checking to see if that's going to equal 0. Now, the key thing here, though, when you solve, you do not move anything over to the right side. You leave the 0 alone, but you kind of just ignore it. That's why I highlight it. You simplify this as much as possible and see if it's going to equal 0, okay? But notice I have that square root of 12. So to get rid of the square root of 12, I'm going to have to simplify it. So simplify the root 12 by splitting it into perfect squares. I'm not sure if you guys remember when we did that, but the perfect squares are 1, 4, 9, and 16. Which of those goes into 12? 4. So I know that's a 4 times what gives me a 12? 3. And what is the square root of 4? 2. So this becomes a 2 square root of 3. And then bring this down, minus 2 root 3. So what's 2 root 3 minus 2 root 3? 0. Did that equal the right side? Does 0 equal 0? Yes. Therefore, my answer is valid. My answer is valid. So x equals 12 is my final solution. Okay. This ends up being a valid solution. X equals 12 is my final solution. All right, so we're going to do another example, but I still see some of you guys copying this down. Our next example should be in your second box now. You should be in your second box now for this example. So go ahead and copy this. We got square root of x plus 5 equals 0. Square root of x plus 5 equals 0. All right, so again, my step 1 is to get the square root of x by itself. So I need to get rid of any addition or subtraction, then multiplication or division. So step 1, isolate the radical. So how do I get the square root of x by itself? Minus 5 to both sides. Thank you. Those cancel. I'm left with the square root of x equals. What's 0 minus 5? Negative 5. And then our step 2 is to undo the square root. How do I get rid of the square root? Square both sides. Thank you. So the square root cancels out the squared. I'm left with the x equals, remember that negative 5 squared, that means negative 5 times negative 5, which is going to be what? Positive 25. Okay. That basically already solved it. So then our next step is to check the solution by plugging it in to the original equation. So my original equation is square root of x, so that's the square root of my x we solved for was 25. And then I have the plus 5. And I'm checking to see if that equals 0. But again, I'm not doing it like leave the 0 by itself. Don't like subtract 5 and square it. Don't do that. Just leave the 0 by itself. What is the square root of 25? 5. And then I got 5 plus 5. What's 5 plus 5? 10. Did that equal the right side? Does 10 equal 0? No. 10 does not equal 0. That means that this x equals 25 is extraneous. So x cannot equal 25, which then means for your conclusion is what? What happened when my only possible solution was extraneous? What did we say? There's no solution, right? My conclusion is that there is no solution. Because my solution was extraneous, that means that I really have no solution, okay? So I know that a lot of people always want to skip this step with the checking, but if you don't check it, you don't know if your answer is extraneous or not. If you don't check it, you're going to say x equals 25, and your answer is going to be wrong because 25 is extraneous, okay? So always, always, always go back and plug it in to check your solution. All right, so the next one is going to be a practice problem. You guys can, again, draw like a line and then try the next example in that same box right there, okay? This one's a practice problem, so you guys are trying this one. All right, go ahead and check your work. I got 81. When you add 9 to both sides, square both sides, you get 81. Then when you go back and check it in, go back and check it by plugging it in. We got the square root of x. X was 81, so square root of 81 is 9. 9 minus 9 is 0, so 0 does equal 0, and it's a valid solution. All right, so let's go ahead and look at the next example. All right, this one is also a practice. So you guys can look back at example number 2 that we did together. This one is kind of like example number 2 that we did together. You guys go back and look at it if you need an extra support. Okay, so our final solution is valid. You're going to end up simplifying. So this 4 root 2, I know it looks kind of scary sometimes, but just break it up. Distribute the square on each side. All right. Let's look at our next example. We're on 4 root x equals 9. And you should still be on like your third box. If you're doing 2 examples per box, you should still be on your third box here. We got 4 times the square root of x equals 9. All right, so remember, my goal is to get the square root of x by itself. So I need to get rid of the 4. Remember, we're doing PEMDAS in reverse, so please excuse my dear Aunt Sally in reverse. Do I have any addition or subtraction? Do I have a plus or a minus sign? No. But do I have a multiplication or division? That's 4. What's the operation in between? That's 4 times the square root of x, right? So what's the inverse of multiplying? Division. So then I need to divide both sides by 4. And then my 4's cancel. And I get the square root of x equals. That 9/4, I can't simplify it. The only thing that goes into 4 is 2. 2 doesn't go into 9. And I'm not going to get a decimal. You leave it as a fraction. 9/4. You leave it as a fraction. All right, now that I have the square root by itself, I need to get rid of the square root by squaring both sides. The square root is going to cancel the squared. We're going to get an x equals. Just like we distributed when multiplication, we do the same thing. We distribute the 2 to the fraction, okay? So this is going to be a 9 squared divided by a 4 squared, okay? So 9 squared divided by a 4 squared. So x is going to equal, what's 9 squared? 9 times 9 is 81 over 4 squared. That's 4 times 4 is 16. I cannot simplify that either. My only factors of 16 are 1, 2, 4, and 8. None of those go into 81, so you're going to leave it as a fraction. And then we need to go back and check it. So to check it, we're plugging it into the original equation. I have 4 times the square root of 81 over 16, and I'm checking to see if that is going to equal 9. That's my original equation, okay? Just like we distribute the squared, we distribute the square root now. So this is the same thing as a 4 times the square root of 81 over the square root of 16. Okay. So then I simplify. That's going to be a 4 times, what's the square root of 81? 9. And the square root of 16? 4. And then notice the 4's cancel, and I'm left with 9. So did 9 equal the right side? Did 9 equal 9? Yes. So then my solution is going to be valid. That means that this here is a valid solution. X equals 81 over 16 is my final solution. We have like 3 minutes left, right? What's this one? Yeah, the bell rings at 31. So I'm gonna stop there for today. We need to finish the lesson tomorrow, so you guys don't have to do any homework tonight. We'll just finish the lesson tomorrow, and you can do the assignment in class.